The bigger the block, the bigger can be your biggest transaction. And the biggest transaction, the higher the worst case, and this worst case cannot be parallelized. So we need a limited consensus layer so that we are sure that builders do not build such a block and this block is not valid. We need to essentially match the constraint on the network level to the consensus level so that it actually doesn't break everything. Parallelization is important, but it's more important is the security aspect. Like 90% is security, 10% is full side optimizations, which may or may not become significant.
Welcome back to PEEPanEIP, a podcast to follow the Ethereum improvement proposals and what's upcoming for the network upgrade. This is episode 151, brought to you by ECH Institute. I'm your host Pooja Ranjan, and today we are diving into two potentially impactful proposals: EIP-7825 transaction gas limit cap and EIP-7934 RLP execution block size limit. EIP-7825 was documented in November 2024. This is a standard track core proposal in draft status and SFI stage for Fusaka upgrade, whereas EIP-7934 is documented in April this year and is also up for Fusaka. This is also in draft status but in CFI stage. Hopefully we will get the decision for inclusion in Fusaka DevNet version in the next all-core dev meeting. For people who aren't aware of network upgrade stages like what is CFI, what is SFI, so on and so forth, please check out our conversation with Tim Bako on EIP 7623 network upgrade inclusion stages. We'll add the link in our show notes. Well, for today, to provide an overview of why these EIP matters, why Ethereum devs are considering including these proposals on the mainnet, we are joined by the CTO of execution layer client Aragon and one of the authors of these proposals, Giulio Rebuffo. Welcome, Giulio.
Yeah, thank you for having me.
Thank you for joining us here today. Well, would love to start this conversation by introducing yourself. Maybe you can talk about your professional background and share what inspired you to join the Ethereum ecosystem and how come you are into documentation of these proposals.
Right. So yeah, regarding the education, the background is a bit complicated because I joined at the client when I was 17 years old. Yeah, so the background there is basically nothing other than I worked at another crypto firm when I was 16, but I was kind of an intern and I joined Aragon when I was 17 when it was still called TurboGaf. So I don't have really a background. I kind of just Ethereum is my background, right? So yeah. Well, I can say at least what I'm responsible for in Aragon. So I was the principal engineer behind the merge in Aragon. Then I kind of led the development of the new data model and some other features in Aragon, which is called Aragon 3 now. So I designed essentially a good part of our new archive node format. I also have worked with other chains in the past with Aragon, of course, such as Polygon and now Arbitrum. And yes, and other than that, I have contributed to EIP implementation, and now I'm the lead of the project, I guess. Yeah, so this is kind of my overall background, which is just Ethereum because it's the only job I've ever had.
Very interesting, very interesting. And joining at such an early age, directly into the blockchain development, it's commendable. I mean, I'm super excited to learn more about these proposals as well as of you.
Right.
I know we had conversation with Alexei Okhnov in the past, and for one of the conversation, Andrew was also here. So good to see another team member of the Aragon client, then called TurboGet. You are right there.
Right.
Yes. Yeah, super excited to have you here. I understand we have two proposals to cover, so without further ado, let's jump into the presentation.
All right, so I'm just gonna begin right away. Okay, so today I'm gonna talk about two EIPs, EIP-7825 and EIP-7934. These are essentially scaling EIPs to essentially increment the gas limit and scale the L1 in Fusaka. Right now, we are essentially aiming for 60 million after Pectra. We're testing it on the testnet, so it's going to go mainnet soon. But with these two EIPs enables us to go further than 60 millions. And I'm just going to kind of explain why. So before actually starting, I'd like to just go over what actually bottlenecks Ethereum very quickly, because I think it's actually pretty important to understand why these EIPs exist. Also, just to give a brief introduction of each EIP, one of them essentially caps the transaction gas limit, and the other caps the byte size of the block. So they're essentially security/scaling EIPs. They essentially dampen worst cases. But I think in order to actually understand this, we need to go and just diverge a little bit into what are the bottlenecks of Ethereum and actually what actually we need to change in order to improve the gas limit, in order to scale L1. So the first thing people usually comes to mind when we talk about scaling L1 is actually the state growth, right? So right now, the state growth actually was kind of a boogeyman that's been throughout the years. What we found out is it's actually not so bad because it essentially the state grows 30 gigabyte a year. And the total state right now is around 250 gigabyte. So here we've got kind of just the growth chart from an article from Paradigm. And you can see that it's really, and we found out that it's actually not so significant right now. Even if we double this, in order to double the state, you would need 4 years. That's 60 million. So the state growth is actually not the bottleneck right now, incredibly. Another thing that comes to mind is the bandwidth, which, yes, it's also on everyone's mind. But the thing is that the block is actually quite tiny. It's essentially 200 kilobytes right now. And 200 kilobytes is essentially one blob. It's one blob and a half around. It's around one blob and a half. So really, it's not even that. It's not a lot actually, right? You can leave as long as you have a controllable worst case there. That's not even a bad thing because 200 kilobytes is nothing. Really. It's one blob and a half. Another side of bandwidth is actually that the CL, actually the majority of the bandwidth is consumed by the CL. The CL does, other than gossiping blobs, which is the biggest data structure being gossiped anyway. They also have attestation aggregation. They essentially constantly pass out messages to each other. And essentially right now, because of the CL, in order to stay synced, needs to be around require 2 megabytes per second worth of bandwidth, while the suggested bandwidth is actually 50 megabytes per second. But the point is that if you actually look only at the execution block, it's not a lot. The most of it is in the CL, and if you increase the block size, you're not actually going to worsen the CL that much because the CL doesn't know about the block. It doesn't know what to do with it. So essentially, on the EL side, it's not even bandwidth, really. Then there is history size, another thing that people throw around. History size is actually much more worrisome than state growth right now because, and it's going to be fixed soon with EIP-44, so whether it's through Portal or it's through some other solution, but people are actively working on this and it's going to be fixed soon. But anyway, just to mention it, history size grows, I think, by 200 gigabyte every year, if I'm not mistaken. Yes, that's per month, so it's 200 gigabyte every year. And yeah, essentially what's going to increase the cost of the hardware, actually, not really state growth. History growth is actually much more worrisome right now, but this is going to be fixed soon. So this is actually not on people's mind too much because this is already kind of a fixed problem. We just need to engineer around it. And also it will take a long time before you're actually going to hit that level anyway, with or without that wax in the gas limit. So it's not even that brought up that much. Lastly, there is computation. Even computation was one of those boogeymans, but actually it's not that bad. Ethereum goes at 1.2 megabytes per second, while the execution clients go between 200 megagas and 1.5 gigagas. So computation is kind of cheap in this moment. It's not even the bottleneck. So essentially, what is really the bottleneck? And in reality, as it turns out, yeah, it's simply that the protocol was not designed around the gas scaling L1, essentially, right? The protocol rules actually are your biggest enemy here. What protocol rules I'm talking about? So, for example, the bigger the block, the bigger can be your biggest transaction. And the biggest transaction, the higher the worst case. And this worst case cannot be parallelized because if it's a one block transaction, you cannot split it, right, during the execution. Clients need, if you want to implement some form of parallel execution, you need to essentially somehow know what the bytecode does, but clients don't know how to do it. So you essentially, if you increase the gas limit and you don't have a cap on the gas limit, you essentially end up with a very bad worst case, which might even grow exponentially. Although we don't really know that, but we don't want to find out. It's mostly just a security EIP. And then there is also a bunch of things and also it's in the way of proving, apparently. This is something I learned today. It's in the way of ZKVM. And so this is something that kind of limits us. So the fact that the transactions can grow unbounded with the higher gas limit. So this comes the first EIP, for example. The first EIP is actually just puts a cap on the transaction and it dampens this worst case. Then there's another weird rules on the protocol, which is on the network layer, which is that blocks that are too big don't get forwarded, they don't get gossiped, they don't get put out by the client. However, these blocks are still valid at a consensus level. So what that means is that there can be a valid block that actually cannot get gossiped. And this can lead to kind of bad DDoS vectors. This is actually led by the fact that, again, we never thought that we might have went to big blocks in the past. So we never actually bothered to fix this inconsistency at the consensus level. So essentially, what the second EIP does, EIP-7934, is it essentially caps, it takes this cap on the network layer, and it also puts another cap on the consensus layer so that it makes sure that block builders and or execution layers do not follow chains where blocks do not match the networking, essentially. So let's go in detail into each of these changes, right? So let's start by 7825, which is the transaction gas limit. So we need to handle the TX worst case in a reasonable way. And also we want to have some degree of parallel execution. So right now there is a lot of interesting clients to implement parallel execution. Aragon is working actively. I know Nethermind and Bezu. Bezu has something experimental, I think, and Nethermind also already have it. So essentially what we want to do is kind of make sure that when you increase the gas limit, we don't end up in a situation where we increase the gas limit assuming parallel execution, but then because you can have one transaction per block, this transaction can completely force the sequential execution, which means that it basically nullifies the parallelization of the parallel EVM implementation and completely throw it off the window and make us actually worse than the normal execution. So we need to find a way to still make this, to still force some degree of parallelization on the chain as we increase the gas limit, so that these optimizations actually work and can be significant. So yeah, as also already said before, there are some weird exponential cases with transactions. And the bad thing about this is that exponential cases actually are really small in terms of impact when the gas limit is small, because the way exponents work, I mean, they work basically by exploding at a certain point and just and then becoming unreachable. So there is a possibility that if we go past a certain point, we might enable some DDoS vector where essentially we have a certain OP code combination that can send that can send the execution to say 2 minutes, right? We don't want that because that would essentially stall the chain. So yes, this is also one of the things. The thing is this, we actually do not even know if these cases exist, but we need to account for them anyway, because in the future, we might add the new OP codes that might cause this, and we cannot, and this actually makes us able to sleep well at night knowing that the worst case cannot get too bad, right? There is still a worst case, but at least it's smaller, it's tinier. It's not as bad as if it just grows linearly with the L1 scaling. Right. So yeah, then there is also other good things, like, for example, there are also other things. This EIP is probably also the simplest. It just implies some basic filtering of the transactions, and it basically implies a new, very simple protocol rule. And yeah, it's just basically a sleep well at night EIP. The main rationale is the security aspect of it. Yeah, and then there is also the parallelization aspect, but it's pretty much it. So let's actually move to the second one, which is EIP-7934. which is actually the limit on the execution block size, which actually is of the same nature of the one before. It is a security EIP. Just to reiterate what the EIP does, essentially, it establishes a limit on the block size that is at the consensus level. The cool thing is actually that every single other chain does this, but we are the only one that don't do this. Like Bitcoin have this, we just don't for some reason. And essentially, the reason why this is important, I'm just going to reiterate it, is that right now we have the limits in these 10 megabyte limits in many places, except where it actually matters, which is the consensus, using the consensus rules and the block building. And right now you could have a block that, although valid, cannot be forwarded. So you can actually incur in some weird DDoS with this. So here you can see, actually, by the way, directly from the consensus specs, I just said to put it here that both in the FP2P and both in the libp2p specification of the consensus layer, you can see that the max payload size is 10 megabytes. You cannot go higher than that. And in both of them, actually, it's maybe bytes, but that's just a detail, actually. Essentially, if you go higher than that, the network doesn't break, but your block doesn't get forwarded, although it is valid, right? So what does this mean? Essentially, you can have a message to large error. And what happens is that you can have an attack where a builder creates a block that is crafted to be above 10 megabytes. The block is valid, and this builder might be able actually to send it through maybe some other channels to other peers. Maybe you can do it through DVT, through other systems. But the better is that once it is propagated through the FP2P, it doesn't work. So nobody sees it. So you can have essentially some sort of chain split, and that's kind of bad. Another bad thing is that these transactions will live on in the mempool, which will essentially make same builder build these kind of blocks, which will lead to which will lead to essentially a quite bad DDoS. You can have the chain down for 2 minutes, and in proof of stake, you cannot have that, because then you have inactivity leaking, and that's very bad. And so, yeah, this is unfortunately what would happen if we went too high. So we need a limit at the consensus layer so that we are sure that builders do not build such a block, and this block is not valid. We need to essentially match the constraint on the network level to the consensus level so that it actually doesn't break everything, right? So yeah, again, it's just a network layer and a protocol layer inconsistency. And we just need to fix this. And once we fix this, what you get is that we can actually probably go up to even 150 million was actually the number this was tested for, and this was designed for. So this is essentially 5 times the current L1 scaling just by tweaking protocol rules, which is quite funny, actually. And yeah, and this is it, actually.
Very well. Thank you so much for this presentation. And first of all, let me congratulate you for getting one of these proposals into schedule for inclusion. That means it will be tested on DevNet now.
Oh, the other one is probably going to go into, by the way.
Yeah, hopefully we'll get the decision on which DevNet version the other proposal will get in by.
Well, 7934 is actually increased the gas limit after 60 million. So a variation of that needs to go in anyway. Yeah, there's been some discussion, but the reason why it was not declined for inclusion is because this change is kind of needed anyway. But people are not sure if the current design is good, but that's pretty much it, essentially, right? So you should expect something similar at least to go in.
That is good to know. At least the people are aware of it, that something is coming up, and we can definitely adjust the limit in upcoming upgrades. So let's start with EIP-7825. 7825 suggests introducing a cap of 30 million gas on individual transactions to help with the DOS attack, as you have explained in block processing. So my first question to you here is, how did we arrive at this number, the 30 million gas number, and what kind of transactions do we think that can be safely accommodated in this 30 million?
Right. So the 30 million gas is actually the gas limit of the Ethereum network when I wrote the EIP, really. The reason why it is 30 million is because, unfortunately, there are some cases that require 30 million transaction gas. For example, the Optimism protocol upgrades, they have to make a call to a contract, and this contract and these contract interactions cost up to 27 million, which is a bit close to the max. And essentially, I just decided not to really try to go down. Many people actually want to go lower because you make the parallel EVM case better. But right now, we decided that since it's a bit uncertain, since we agree that this is needed, but it's uncertain whether going lower actually is possible, and it doesn't break applications such as optimism, contract upgrades, it basically made us still stay at 30 million and then reconsidering it for Amsterdam. That's essentially our stance right now, basically.
Right. Yes, and I was following the Fellowship of Ethereum Magician thread for this proposal, and I noticed that there was a suggestion of setting the cap a little lower at 2 to the power of 24 or
Yeah.
minus 1, around 16.7 million. So why is that we are going with 30 million and then trying to think of like whether increase or decrease the gas limit? Why not begin with the lower limit here?
Because the priority, I think, is to scale the L1. We don't want to break application yet. So I think looking just at the numbers here, a 5x improvement from now is something that we need, and it's something already pretty significant. If we actually decide to go to 250 million, and I think that it's not really worth breaking application. I think most of the benefit it's in the scaling. Then yes, we can decrease it in the future, of course. But unfortunately, for the first iteration, I just wouldn't do that. I just wouldn't do that because that's not why I wrote the EIP, really. Right? Parallelization is important, but it's way more important is the security aspect. Like 90% is security, 10% is full side optimizations, which may or may not become significant.
And the good thing is here is we got rough consensus in the meeting. So hopefully we will keep the limit and we'll see what to do, like if we have to make changes at all. You mentioned about parallelization. So could you maybe explain it a little bit, how it is like nullifying the parallelization effect here?
Nullifying, it's not nullifying, so the EIP doesn't nullify it. Without the EIP, it can be nullified if you have a parallel EVM implementation, like Nethermind does, right? Because if you have a one transaction block, right, if you only one block with a single transaction, you cannot parallelize the transaction. It's impossible, right? Because it's only one transaction. Like, what do you run in parallel with that transaction? Nothing else, because there is no other transaction in the block, essentially. So this is actually the parallelization aspect. Essentially, if you have only one transaction, that essentially in a computer you have multiple threads, right? Multiple like mini computers, you can think of that way. And essentially the way the implementation of the Parallelization works is that you essentially put on this mini computer one transaction and then you let them execute it. But if you have only one transaction block, then essentially you just have one computer doing the work. The other one don't do anything because it's only one transaction in the block. Yeah, that's it.
Yeah, that makes sense. Well, I understand the proposal suggests that if there is a transaction over 30 million gas, that will be rejected with an error. So where exactly is that enforced? Is it at the JSON-RPC level or the transaction pool or doing the block validation?
The 30 million is a block validation. The rest is kind of an implementation detail, in my opinion. So if it's in the validation, it's everywhere else, right? Because if the transaction is invalid in the validation, you don't want it in the transaction pool, and also you don't want it even to be considered in any other part of the Ethereum protocol. So I think everywhere is the actual answer. You need to put this check kind of everywhere.
So do we want to specify this in the proposal? Like if it is at validation level, definitely it's going to be everywhere. If we specify it, maybe it's add more clarity to the proposal.
Yes, I could add more clarity proposals. I think I can do that. Yeah, why not? Yes, I can do it. Yeah, sure. But yes, it's validation. It's purely validation. But validation also entails that everything else also needs to change because you don't want invalid transaction in the transaction pool, right?
Yep, that makes sense. Very well. We generally understand that gas is a critical part of Ethereum architecture.
Right.
How does it affect users and developers today from your perspective?
So my personal opinion on this is that probably in scaling that one is probably the most important thing we should do right now because it's essentially the one thing that has demand on the network. We have to think that we sell blobs and gas limit. The blobs is kind of there are enough blobs, but there is definitely not enough gas limit, and people have been complaining about it for like years now. So essentially, we need to get on par. We need to finally get our stuff together and actually fix this because there is a lot of benefit and improvement that come from a gas limit. Just to give an example, 7702 is completely useless without a decent gas limit. Like a transaction from a smart wallet will be too expensive on Ethereum mainnet if there is usage, if the gas limit is too low, right? Or nobody will actually pay transaction for their users if the transaction costs too much money, right? Like most of these UX changes all depends on scaling. Without scaling, 7702, for example, in my opinion, is completely worthless, right?
Yeah, I understand 7702 is one of the most important EIPs, those
Yes.
shipped with the Petra upgrade. So it would be helpful to have additional proposals which can help this proposal work the way it is expected to.
Yeah, I
So
think now it can be only used on L2s. On L1s, I don't really think it will get much adoptions until we increase the gas limit. That's my view on it.
all right, then sooner this is on mainnet, better for the developers working on
Yeah,
contract side.
it's better for everyone.
Well, I'm curious to hear your thoughts, because this is kind of limiting here, the gas limit here. Do you think it will introduce any kind of barrier for developers who are, or maybe planning to deploy large or complex contracts?
Contracts are limited by size right now. So there is a worst case already specified and it's much lower than 30 million. So the contract is not the problem. The real problem that was actually, I mean, there is a concern that was brought today to ACD is that account abstraction bundlers cannot do one transaction per block. But I think there is consensus that one block transactions are not really good for the network. So but that's kind of the only concern I will think of. I think really 30 million gas is what we had for the past 5 years, right? So essentially, what I would answer the question is that you can still do everything you could do before, but you can also do more, right? It doesn't limit you from before, but it just makes things better. Essentially, that's how I would answer the question.
Very well answered here. So, just a follow up on that. Do you think this proposal will impact node operator, validator, or light client in any way, either positive or
No,
negative?
it won't. It won't impact. Well, other than the implementation, it won't impact anyone. Like it's a very small change. Yeah, it won't impact node operators too much. Like they won't notice it. I mean, they will see more gas limit maybe, but that's a second order effect. They won't see any first order effect of this proposal.
Very well. Just out of curiosity, are you aware of any L2s or any other EVM chain those may have implemented similar cap or limit on the transaction level?
Other, well, I mean, the only chain that implements a cap that I know of is Solana. The rest doesn't, I think. Yeah. I don't think there's an EVM chain that does it, that has a cap right now. At least that I know of.
Very well. We can maybe now switch gears for the next proposal, 7934. So for that, my first question is, why do you think it is necessary to cap the RLP encoded block size at 10 MIB? How did you reach to this number here?
Because it's the number in the networking specification. That's why. The whole point of the IP is to match this constraint with the core protocol, right? So we have to use the same constant which we use in the network, which right now it's 10 megabyte. That's it.
Right. And this proposal, it actually separates the block size limit from gas usage. Why do you think it is important? We already have the other proposal, 7825, which is for gas limit here. Do you think both together can help against the DOS risk, or can independent proposal also would have worked?
No, I don't think, no, these act on different levels. So I don't think one proposal would have cut it, because the thing about this proposal is that if we go past 100 million gas limit, we essentially get the point where this attack is possible, right? But there are two different attacks, right? You can imagine one is a security AP that dampens and potential exponential cases, and this one, you're essentially just fixing the protocol. Like this just fixes the protocol. Like the fact that this check doesn't exist is a bug in the protocol, ultimately. It shouldn't happen.
Yeah.
So they have to be separate, unfortunately.
Sure. I have seen many proposals which are kind of a bug in the protocol or something that we ignored at the time because that was not of high importance. But we have those proposals to kind of fix it. And people are generally supportive of such proposals because that is trivial and it should be fixed now.
Yes. So this is one of them.
Good to know that. Well, when we are talking about gas limit and block size limit and everything, one question that comes to mind of mostly developer is about security consideration. So what would you say that any implementer or developer should keep in mind while implementing these proposals?
I think the only proposal that needs to have some serious thought behind is actually 7934, which is actually why it hasn't been as scheduled for inclusion like immediately. It's because essentially it's not complicated, but it needs some thought behind it, right? Because the block builders now need to essentially count the size of the block they're building, right? It's probably trivial, and there is already a pseudo implementation from Nethermind that shows it is kind of trivial actually to do. And yeah, so the only thing that you need to keep in mind is that if you want to implement, to put the cap on the block building, you need to choose a heuristic that makes sense and that is in the constraint of the new consensus rule. That's all I could say to an implementer, really, about 7934. 7825 it's so simple that I don't even know what I would say. Like, just put the if statement, honestly. That's what I would say to implement.
Sometimes the documentation can be misleading. If I'm looking into these two proposals, I see the bunch of security consideration for 7825, but only one for 7935. So,
well, security consideration, well, okay, maybe these are like, I don't write EIPs usually, so I don't, so I just thought that the security considerations was something for the protocol, like in general. Like, for example, if you increase the gas limit in a proposal, the security considerations would be home stakers might be in danger, for example. So I really didn't have in my mind implementers when I wrote the security considerations. Yeah.
but these proposals are coming from client developers because they also have the perspective of what's get into the client and some idea of implementation already.
Right. Yeah.
Very well. That kinds of conclude for the questions which are specific to these proposals. Anyone on the call, if you have any question, please feel free to drop it in the chat and we will invite you to take the questions. But in the meantime, we can have some easy, relax, and fun time. So we are moving to our next section, which is called Rapid Fire Round. So, Giulio, in this round, we generally try to collect answers from you to know you better. How do you feel about the environment, the Ethereum, and things like that? So, it could be one word, and we can provide you some options you can select from that. Sounds good?
Right. Yes. Sounds good.
My first question is, what inspired you to get into Ethereum? Open source, economic decision, or decentralization?
The permissionless aspect of it. Before a client dev, I actually was studying Solidity. The cool thing about deploying contracts on Ethereum was actually that you could essentially manage, I wouldn't say people's mind, but you could manage something that has value in a programmatic way, and you can do it in a permissionless method. And that's, I think, why I came into Ethereum. It's because it is permissionless. That's the most important part for me of Ethereum. Everyone can join it.
Awesome. And I think you have partially answered my second question. Still, I'm going to ask this question from you. If not client development, what would you build?
If not client development. So, well, this is actually funny because before, actually, when I was 14 years old, I was working in a robotics lab in Italy. I wasn't working, I was kind of being there, like I was just present, right? So I think that if blockchain didn't exist, I would have unironically become an AI developer, unironically. I would have ended up like that if blockchain didn't exist, if blockchain did not exist. But I ended up becoming a blockchain developer, unfortunately or fortunately.
Fortunately for us.
Yeah, thank you.
Well, my next question is, what excites you most in Ethereum now? You can talk about any feature or any priorities in the client.
So I haven't been excited, and don't take this answer too badly, but I haven't been excited since the merge because that was such a huge feature and that nothing comes close to it. But I would say that right now I kind of look forward for Fusaka and for the L1 scaling. I'm not super stoked for PEERDAS, not because I don't like it, but because kind of I don't think it is as important as L1 scaling right now in this exact moment. But anyway, yeah, that's what I would say right now.
Very well. There are so many proposals, so many features. So I'm sure that there would be something much more exciting coming up in the future. I don't know if it can be matched with merge, but definitely good features are on the way.
Yeah.
Yeah, well, my next question is, where do you learn the most? Is it Magician Thread? Is it Developers Call, the Core Dev calls, or Crypto Twitter?
I learned the most in the past. It was a mix. Right now, I learned the most through ChatGPT deep research. So, yeah,
Yeah,
that-
AI
that's
is
how
the
I
best
learned.
help these
Yeah,
days.
yes, that's how I learn the most now. I basically talk to it every day now, just to learn the new technical stuff, just for fun.
Good. Well, how does a EIP idea come to your mind? Like, is it by looking into the real pain point coming up from technical debates or just random thoughts?
Oh, shower thoughts. Like I think I came up with both of them when I was on a train in vacation, and I was just casually chatting in the gas limit testing group chat, and that's it. That's how I came up with both of them.
Relax minds give you better ideas,
Yes, relax mind. Zen.
right? What's one thing in Ethereum that developers need more? Better tooling, clearer specs, or better coordination?
I think right now, if you're talking about app develop, I think better tooling. I think with 7702, that part will be sped up because now there is actually decent UX on which we can build tool from. There is a new framework on which people can build wallets. If you're talking about an implementer, I think probably specs is the best things really for us, as far as I can tell right now. I think, unironically, this is kind of probably not popular opinion, but I think that implementing hard forks of Ethereum is not actually that difficult, because the difficult part is actually figuring them out and speccing them. So I'd say specifications.
Cool. You have started pretty early. So, if
Mhm.
you have to see Ethereum after 10 years, how would you like Ethereum to be known for? Like, would that be a best coordination layer project, an application platform, or anything else?
I'd say it's a hard question to pinpoint, but I'd say maybe I would still throw around the word Internet of Finance, because that's essentially what I think is the overarching goal of the blob roadmap and the L1 scaling roadmap. These two roadmaps kind of all achieve this kind of having this economy of the internet. You have a robust base layer, then you've got kind of this other app chains. We can call them app chains or just L2s that serve the users in the same way a bank would, to some extent, right? Not exactly like a bank would, but with the same interface and with the same feel, right? Hopefully better.
Right. Well, you have worked since March, so you have seen so many proposals. What would you say your favorite EIP, which is not documented by you?
Oh, my favorite EIP, I think right now it's the block level access list, because it's a new EIP. It's actually very recent, but I think it's kind of brilliant because it fixes the protocol. It allows for very cool things. It allows for partial statelessness in a very elegant way. It's very simple, and essentially it's just very simple EIP, very elegant, and it might even enable replacement for the statelessness effort, which is very complicated. And that's basically it. I think it enables a lot of cool things like better block processing, some form of partial statelessness, and that's it. Yeah.
Sure, we will look forward to that proposal. Well, as per your development style, what would you say it is? Do you just plan everything, you build and refactor, you hack it, and then clean it up later?
I just do things like I don't even hack it. I think when I have an idea, I just implement it, see if it works, and then maybe refactor it. But usually, it comes well at the first try in terms of code quality. I'd say I'm very proactive when I code. Like I just implement it. It's basically we implement it and we test it and that's it.
We need
Um,
a mix of all sort of brains, so it's
It's
good to know.
it's yeah. It also depends on the things, right? It also
Right.
depends on the things. Usually it's implementation and then testing and then it's in. If I usually don't hack anything, I usually always try to write decent code at the first try because it's not that difficult anyway to write decent code. So I
Good.
just do that.
Very well. Well, in Ethereum, what would you say is the most underrated part as of now? Like, is it JSON-RPC spec, testnets, or anything else?
I think nothing is particularly underrated. No, I don't think anything is actually underrated. Maybe something very underrated is something. I mean, if you asked me this question 6 months ago, I will say the L1, but now everyone changed their mind all of a sudden. So that's bad. And I'd say that I actually don't have an answer. I think maybe testnets are underrated, actually, because people don't think about them, but actually they saved us from having a bad vector upgrade. I mean, those testnets, I mean, Sepolian and Oleski had incidents, and Oleski died for us, kind of. So we need to appreciate Oleski in some sense.
Right, and there are now some community debate also coming up for having testnets for support of like ongoing applications, which depends upon these testnets. So
Yep.
definitely those have been helpful. Well, what would you say is the overrated topic? Is it tokenomics, MEV drama, or anything else?
I think right now is kind of the tokenomics, probably. I'd say it's the tokenomics. There is a lot of talk about on how to price things, but I think that people kind of miss the point that the main value of Ethereum is its use. And unless we improve the UX and how we use Ethereum doesn't, like, the tokenomics don't get better. If you just charge more for transactions, you're not going to get better tokenomics. I also kind of think the same about blobs to some extent. But yeah, I think we need to improve the usability of the chain. Tweaking tokenomics is looking at the problem with the in the wrong direction, from the wrong side of things.
Right. Yes, I'm also in agreement. Like from Ethereum's point of view, we should focus more on the L1 improvement at this point of time, and then we can look into other aspects which are related. Well, my final question for today is like I understand you have been a client developer, you have started with directly coding and things like that. But since you have documented a proposal, my last question for you here today is what is the hardest part of writing an EIP? Was it just naming it? Was it documenting, getting consensus? Or the other aspects like writing motivation, abstract, and rationale of the proposal?
No, it's literally just document. It's actually just shilling to other people. It's pushing for it. There is always someone that disagrees with you. So, but even if you, I mean, the API I actually wrote, I don't think actually, I think they need some tweakings because actually I don't think they are that great in terms of how they're written. But in general, that doesn't really matter because people still want them. But I think the biggest problem is that some people kind of complain about them. As always, there is always people that are always grumpy and they don't want to implement anything or they won't implement all the things they think are important. So pushing them in ACD is actually the hardest part of the process, I think. I think even if you get the other things wrong, as long as you can shield it and it's useful for people, that's what matters, really. Yeah.
Well, I think it is also the timing of the proposal because we have seen 3074 for quite some time. They had done everything, tried to convince people. But yes, all of these things together helps a proposal get selected for the network upgrade.
You should ask this question to the UF team.
Of course.
Yeah. This question to the UF team. I think they will answer similarly to me.
I'm sad about this part that I have seen some of the EVM proposals not getting included. I remember one of the proposals which was like out of the upgrade just a few days before it went on the mainnet. So it's sad to see so many efforts getting.
I actually was not present when that happened. I heard of it, but I actually wasn't born, I think, into Ethereum before.
Yeah, it was proposal 2315, 2315. That was like.
Is it Greg Colvin proposal?
That's correct.
Okay, yeah.
That's correct. So I must congratulate you for having these two proposals selected for the upgrade, and we look forward to have these proposals deployed on the mainnet. After successfully deployed on multiple versions of DevNets and the public testnets that we have got over here.
Right. Yeah, I hope they get included.
Well, thank you so much, Giulio, for taking out time and sharing about EIP-7825 and 7934. We are so looking forward to see these proposals on mainnet.
Okay, good. I'm happy to hear that.
Well, I would also like to extend my thanks to my colleague Akash and Valeen, who helps us support these proposals get to the public. These episodes come out in the form of recording so people can learn and share it with people who are interested in learning more about Ethereum. For our listeners, we will include the links to this proposal, their discussion threads, as well as the presentation link in our show notes, so please check them out. Until next time, keep following Ethereum, keep reviewing proposals, keep building, and stay curious. Thank you all for joining us here today.